Welcome to our demonstration of a weather prediction workflow using Geoweaver. To start, ensure that you have a suitable environment on your host machine to execute the workflows seamlessly. If not, create one. For this project, I have Conda installed on my local host and will use it to manage the environment. I've already created all the processes needed for this project. Let's view these processes one by one to understand their function and how they contribute to our weather prediction workflow. A process to describe or check the data. In the first process, I import the pandas library to read the data file from the local host, allowing us to describe the dataset. A process to clean the data. In the second process, the data is cleaned by changing the date format to datetime, then using ffill to fill in missing values. The cleaned file is then saved to the host. A process to train and test the model. The third process splits the cleaned data into training and test datasets. A linear regression model from the sklearn module is then trained, and the model is used to predict the weather on the test data. A plot is created and saved on the host system. With all processes in place, let's add these processes to Weaver one by one, and then connect them accordingly by holding the Shift key and dragging the mouse from one process to the next. After connecting the nodes, let's inspect the code of each process by selecting a node. A side panel appears with a code editor and a series of options at the top. These options include History, to view the process execution history, Execute to run the process, a checkbox to log the process output, a checkbox to skip the process when running the workflow, Save to save any code changes, a view adjustment to switch the log section's position, Maximize to expand the panel, Cancel to close the panel. With all processes now in place and connected correctly, the next important step is to save our workflow. Click on the Save icon from the toolbar within Weaver. When prompted, give your workflow a meaningful name and provide a brief description that encapsulates its purpose. Then, select Confirm to save your settings. Let's execute the workflow by selecting the Play icon from Geoweaver's toolbar. This action will open a window where you must select the host and environment for the execution. I'm keeping localhost as it is, but changing the environment to base, which is managed by Conda. Once set, click on the Run button. After clicking Run, you'll be prompted to enter your password. Input the password and click Confirm to start the execution of the workflow. Upon successful execution, let's check the logs from each process by inspecting them. The first process log shows the data's stats. The second process log confirms the cleaned data was saved. The third process log contains the predicted weather values. Finally, let's view the plot saved on the local host. Using Geoweaver, we've effectively managed the entire weather prediction project, highlighting how it can greatly streamline your data science workflows.